Thank you. As she said, my name is Austin McBride, and today we're going to talk a little bit about cryptocurrency, how it's a gold mine, and how you can protect a couple of measures you can do to protect your environment. First, we'll talk a little bit about cryptocurrency in general, and then cryptojacking, then phishing, and then a little bit about alternate coins and exchanges, and then finally about measures to protect yourself. So a little bit about me. One, I got a haircut, so I look a little different now. But I am a threat analytics researcher at Cisco Umbrella. I have a BS in data mining and economics. I really love crypto. My hobbies are working and basically algorithmic crypto trading, and of course work. So a little bit about the team that I work with. It's called Cisco Umbrella. And we basically mix data science and network security. And so we call that big security data. We process about 180 billion DNS queries a day, and that's roughly a little bit less than 3% of daily DNS traffic globally. So we get quite a decent sample as far as DNS queries are concerned. We also see a lot of new domains that have just been registered and have not really been visited frequently. And now that we're a part of Cisco, before we were OpenDNS, now we have all of Cisco's data as well. So daily activities for myself and other people on my team are security analysis, distributed systems, big data engineering, and data visualization. So a little bit about cryptocurrency. So as we all know, cryptocurrency had a pretty meteoric rise. It's not quite there at the moment. It's about 200 billion, but within a one-year period, we went from 26 billion in market cap all the way to 835 billion, which is not something that we've ever really seen in other traditional markets. So with this, there's a lot of opportunity, right, for anybody to make money, and especially malicious actors. So with the going mainstream and becoming more popular, a lot of individuals are going to get into this space, and it's going to be a ripe spot for malicious actors to go and take advantage of people who don't know much about blockchain or cryptocurrencies. It is underregulated, and it's highly volatile, and there are a lot of malicious actors that are wanting to steal your funds. So I'm going to talk a little bit about cryptocurrency regulation. So to start off with, I think Japan has the most comprehensive structure at the moment for regulating, especially exchanges in your country. I think it's great. I would say that most other countries are not anywhere near the understanding of blockchain or exactly how to regulate it, especially with the different governing bodies. So it's kind of an idea, right? We started off with the Mt. Gox compromise in 2014. Then the FATF, Guidance Risk-Based Approach to Cryptocurrencies in 2015, very progressive. Then the Payment Services Act in 2017. Now a lot of people go through Know Your Customer. Everything is complying to anti-money laundering rules, and then there are frequent audits to make sure that the books look okay. Then we had CoinCheck, of course, that happened in January. Then the GVCEA in March of 2018. Generally, where there is money, there will be malicious actors that want to take it from you, right? And in this case, most of it's going to be external. Most of the threats that you'll see that involve cryptocurrencies in your environments are probably not going to come from Japan. Most likely is going to come from Ukraine or another foreign operator that is just operating in your environment as much as possible to steal funds. So one of the reasons that it's actually so attractive is that it's very lucrative, and it can be hard to spot if you don't know what you're looking for. Crypto exchanges do not necessarily have as robust security measures in place that traditional equity markets do, stocks, bonds, et cetera. And so it's very easy for malicious actors who have an understanding of that to easily infiltrate and steal funds. It's also very anonymous, depending on the coin, and with an asset valuation that fluctuates quite a lot. You can basically steal coins in 2 or 3 days or a week. They can be 30% worth 30% more than they were originally. So it's very, very lucrative, and it can be used to of course, buy Lamborghinis and things like that, but it can also be used to buy additional malware or infrastructure to make even more impact and damages. So now I'm going to talk a little bit about how cryptojacking fits in to the mix. I'm sure you are all very aware, but the basics of crypto mining is basically you're verifying transactions of others, and then you're rewarded for verifying those transactions. In the case of Bitcoin, it kind of can differ depending on what coin. Cryptojacking is really just the hijacking of computer resources. And there are a few other speakers that talked about this in the conference. And basically, it's just using your GPU, CPU, or cloud computing services to mine cryptocurrency. So keeping in mind with the about 180 billion DNS queries we see a day, we've seen a tremendous increase in the amount of crypto traffic just in the last 8 months. And the majority of the traffic is from crypto mining pools. We see a lot of Monero, of course, and some other coins. And they actually happen to affect a lot of different industries. It's not just financial services, healthcare, a wide variety of industries all are seeing this type of traffic in their environment. And there are also some malicious actors that are dropping mining software, and it persists in your environment as long as it's connected to the internet. So looking at a distribution of industry, in the US specifically and in Europe, you can see that higher education, energy and utility companies that typically have hardware that is older and not necessarily patched as frequently as it could be. Healthcare have surprisingly hold quite large percentages of the amount of traffic that we've seen cumulatively over the last 8 months. The top industries kind of fluctuate, as we can see from the last 2 to 3 months, or every 2 or 3 months they fluctuate. But higher education is almost always on top. So this means students who have free electricity and free internet in their dormitories are running mining rigs. And so this can be costly for educational institutions. Looking at the kind of geo-distribution of the traffic, we see a lot happening in the US and in European countries as far as crypto mining goes that is malicious in nature. Not necessarily global crypto mining traffic. And then, as you can see here, we've got a bar chart of a couple of the different country codes that we see quite a bit of traffic in. So you may ask yourself, what type of company is most targeted for crypto mining activity? And I would say that it predominantly is focused on smaller businesses or medium-sized businesses. And the reason for this is generally those businesses do not have dedicated incident responders, people who are monitoring network traffic, making sure things are actually consistently working as they should. And so that is why we see normally companies, 10,000 employees or less, are being targeted for this type of activity. We can also see that with the use of mining pools for Monero and some other types of coins that you can mine, the market fluctuations in value and the difficulty of the mining can actually impact whether or not you're seeing that traffic in your environment. So when the market is down and the mining difficulty is high, you'll be less at risk for this type of activity in your environment. But when the market cap is going up and we're approaching 1 trillion in market cap, you're going to see a lot more crypto mining in your environment because it is cheaper to operate and more lucrative. And we've also seen that as the market has taken a dip recently in overall value for cryptocurrencies, we see a lot more phishing. So mining costs, you think, okay, you might ask, well, how much does this really cost malicious actors to mine in my environment? And really the cost is pretty negligible. Using popular web miners like CoinHive, or there are several that you could use, generally they'll take maybe 30% of whatever you mined as a fee, and then the rest of it they can put in their pocket. And then the upfront cost of them getting this mining software, whether it's JavaScript or physical malware software in your environment, is really just the cost of however long it takes their time and money to get into your environment. So this is CoinHive, very popular online miner. It mines Monero. And here we can see that really it's not necessarily just larger corporations and servers and AWS instances that are being targeted. We see this happening in smartphones. We see it on websites as JavaScript exploits and then individual machine targeting. You've probably seen a lot of news stories about different breaches and hacks. Some are in cloud AWS instances with basically weak Kubernetes passwords, right? But we also see malicious actors infiltrating sites that deliver content like video, as well as news websites where they know that the user is going to be on that domain for at least 30 minutes to an hour consuming content. That way they maximize the amount of money they're making per machine. So here's an example of a
こちらの例は JavaScript のインジェクションであります。これは非常に簡単なものであります。もうほんの数行のコードになっております。ではこれでもうすでにビジネスをスタートできるわけです。このウォレットを指定し、いくつかのパラメータを入れれば、これでお金を入手することができるようになります。多くのサイトではこのようなスクリプトがインジェクトされたということさえも気がついておりません。でこういったマイニングをしているときにも、特にそのパフォーマンスが落ちるといったようなことは見られないでしょう。背景でそれが動いているだけでマイナーが攻撃をしているということはほぼ気がつくことはないでしょう。で私がやってきたことということで、クラシファイアというものを見てまいりました。で、DNS のコードがたくさんあるんですけれど、ウェブベースのマイナーとそれからソフトウェアベースのマイナーというものがあります。ウェブベースになりますと、これは急激にトラフィックが増えるということがあります。例えば15分、10分ぐらい続いてそれが落ちるということになりますが、ソフトウェアベースのマイナーですと、このクエリーはその持続して行われます。例えば2日、3日にわたって持続してマイニングがされるということであります。
Means that one, either an employee installed mining software in your environment, and they shouldn't have, or two, an external party was able to get into your environment, install software, and they are sending the funds that they're mining in your environment externally. So with the second case scenario is much worse, because if it is in fact the case that someone external puts software in your environment, what's to say that tomorrow they decide they don't want to do mining and they want to encrypt all of your corporate data? This is a way of determining quickly if you have a potential threat of an outside incursion. So now I want to talk a little bit about crypto phishing. So phishing has obviously been around for a long time, right? We have normal vectors like email. We've seen a huge surge in search engine ads, so Google and other search providers with ad poisoning. And then with a lot of different communication channels, Slack, Telegram, Discord, Twitter, all the normal ones. So here is an example of some Google advertisements there for My Monero. My Monero is a popular Monero wallet. And if you can see here underneath the Y on the ad URL, it's not quite right. We see a little dot. And then on the second one, same, we see a little mark above the O. So essentially what the malicious actors are doing is they're using Punycode to simulate a domain name that looks similar to the legitimate site. And if you aren't paying close enough attention, you put in your credentials and lose your funds. So here's actually both of those sites. They're currently no longer live, but these are the exact copies of the sites. That's the first, this is the second one. And just because you see it's HTTPS really doesn't mean you're safe. There are a lot of providers these days that offer wildcard certificates. And so anything that's hosted on a specific IP is blessed with the HTTPS tag, and That doesn't necessarily mean you're safe, so don't rely on HTTPS as a means of safety. And then here's just another example of DuckDuckGo, another popular search engine. So to drive this point home a little forward, I'm going to talk about how easy it is to make a Google advertisement to get people phished. And this doesn't necessarily just apply to cryptocurrency or crypto phishing. It could be applied to any phishing vector. It's very, very effective. So a couple of things to note about Google AdWords specifically. You have to, basically the redirect does not happen in the ad. If you click on an ad in Google, it has to, the domain that's registered here has to be part of the landing page that the user ends up on. So you have to own it or at least reference it. And then the domain that's displayed in an ad cannot have a different site name. So essentially, you would have to create a subdirectory or another page on that site to do phishing. So that's what I've done here. I've hidden it and I've put wallet/I'm going to phish you. So in this use case, this specific one, I would, as a malicious actor, have to somehow infiltrate and get login credentials for blockchain.info, which would not be a very easy task by any means. But what I could do is I could also set up a phishing campaign to get someone who works at blockchain.info who operates their Google AdWords account. And I hope if I can get their login information for Google AdWords that it may also be the same credentials for their site, and I can then have the website, who's legitimate, pay for ads that are malicious, and I can have the redirect page to my phishing site to get credentials living on blockchain.info as a subdirectory. So you have to be careful because malicious actors will take at least 2 or 3 different steps out as far as possible phishing vectors in order to get credentials, and they're hoping that you're using the same credentials for multiple sites. So here's an example of the puny code being used heavily in Google AdWords and other ad sites. Here the I is not quite right. And that's how it actually is displayed when you look up the domain. But of course, web browsers try to clean up those types of things for users. All right, so now I'm going to talk a little bit about cryptocurrency exchanges and altcoins. So we discussed before about phishing scams. Here are some advertisements for there, but we also see a lot of things happening on social networks and communication platforms. This is something that was mentioned by Philip at Coinbase yesterday. It's very easy to entice some people. If you send me 0.2 Ethereum, I'll give you 2 Ethereum just because me as Binance, I love you as a customer. Right? This doesn't work for the majority of people, but it still works for some, and this is still lucrative enough for them to walk away with quite a bit of funds. So I'm going to talk a little bit about Binance. Quick raise of hands. Anybody here use Binance as a trading platform? All right, we've got one. All right. Got a few in the audience. Good. I love Binance as a trading platform. It's very simple to use, easy to manage. They have a lot of security measures in place to keep you from being phished or sending funds to wallets that are not yours or you don't want them to be sent to. So right here we have an example on the left of a malicious site, and on the right the legitimate site. The only difference being is that there happens to be a V in the domain name on the one on the left. Which is, of course, malicious. The infrastructure and how the malicious actor set this website was quite good. All of the stock information updates at the exact same time. If you were to click on any of the links on the phishing site that would lead you to logging in within 1 or 2 clicks, they would keep you on the phishing site. If you were to look at wikis or support or information about contests, they would forward you to the legitimate site. And they did this so they didn't have to replicate the full infrastructure of the website. So let's pretend that I was not paying attention and I'm going to log into this phishing site. So I go to the login page, I put in my email and my password, I do a little CAPTCHA, and then you say, but wait, Austin, what about two-factor authentication? That'll probably save you here, right? Not necessarily. So this is what is known as a 2FA bypass or a man-in-the-middle attack. So I'm the victim, and I am on a phishing site, one of the ones we were just looking at. I give him my credentials. He forwards that to the legitimate website, puts them in. The legitimate website prompts for a two-factor authentication code that is sent to me, and I still don't know that I'm on the wrong site. I put that information into the phishing site, and then the malicious actor uses that code in order to get into my account. And then normally after that, they forward you to the actual website to make it seem like there was just a login glitch. So you have no idea that you actually just gave someone else access to your account. And most of the time, they actually do not immediately steal your funds. So if we look a little bit more closely at bivnance.com, the malicious domain that we were looking at, using a tool that we have called Investigate, we can look at information, whose information, and some other information as well, that gives us insight into, is this actually legitimate or not, or who is doing this? So in this case, we see that the register name is the Center for Ukrainian Internet Domains. Binance does not operate in Ukraine at the time, and so this is very suspicious. The email registration, black13@unseen.is, this is an email that prides itself on anonymity and is not what you would ever think a large exchange would use as their email registration email. So there are a lot of red flags here, okay? And then what also is interesting is the IP that this domain is hosted on is not an IP that Binance uses for hosting their infrastructure. So we're going to dig a little bit deeper into, well, who is this black13 unseen at unseen.is? What's interesting is that you can see that they're also interested in MyEtherWallet. So not only are they wanting to get credentials for your exchange, but they also want to get credentials for online wallets where you think your funds are actually secure, but maybe not if you end up getting phished. And down here you can see a lot of other domains that they have set up at varying stages trying to pretend to be Binance. So some are live, some are prepping to go live and for phishing sites. So now altcoins. Now that we have all this stuff about phishing, this is where it kind of gets really cool and very scary. So another tactic they use involves pump and dumps. So it is you're pumping the price of a coin, and then you sell all of your coins at the top, and you use a bunch of other people's funds. So what the malicious actors did was they phished a couple of hundred exchange accounts, and then they created trading API keys, and then they didn't do anything for like a month or two. And then they set up a bot to automatically trade to basically liquidate all of the coins that were in those wallets into Bitcoin, and then use that to purchase Viacoin. And the reason they chose Viacoin was because the liquidity of Viacoin was only about 11.5 Bitcoin. So that means it was very easy for the actor to buy the whole order book, all asks, all bids, which essentially would allow them to increase the value of that coin by 10,000%. And what they did is they had a couple accounts that they had their own Viacoin holdings in that they had procured before, and just lied in wait and were going to sell their own holdings at the top and walk away with about $32 million. But unfortunately for them, it didn't happen. The exchanges noticed that a 10,000% increase in any asset is very unusual, and they basically blocked withdrawals and deposits for those funds. So they didn't it impacted individuals and the fact that they lost a lot of their asset value when their funds were liquidated, but the malicious actor didn't walk away with any of the money. But if the exchanges did not have some of those security measures in place, which is the case of a lot of small exchanges, they don't have halting on trading for huge jumps in asset prices, they could have walked away with a lot of money. So now that I've talked a lot about well, crypto phishing and cryptojacking, I want to talk a smidge more about how you can protect yourself with different tools. So DNS level identification of crypto mining and cryptojacking is very, very effective. So looking through your DNS query logs to see if things like CoinHive and other mining pools like XMR minerpools.xyz is a very popular one. You can see if any of your machines and your environments are querying these, and then you can know that, okay, well, either an employee went to a website that has a JavaScript exploit and mined a bit of currency, or maybe there's a piece of software in my environment that is mining that I need to look into. For cloud computing instances, and this was mentioned before in one of the previous talks, look for increases in utilization of CPU for your AWS instances. They would normally only do 10 or 15% increase in utilization, so that when you get your bill, it seems higher than normal, but it's not too high. And so that they want to basically operate for as long in your environment as they can without being caught or identified. And they're also hoping that the longer they wait, the value of that currency goes up considerably. So one of the models that we use at Umbrella is the co-occurrence model. And so it's kind of like guilty by association. So if we know that one website is malicious, and we look at the time that other sites were visited, basically 15 seconds before or after, we can basically say, okay, that seems a little suspicious if all of the users that are forwarding their DNS to our service are going to the exact same domains within a certain time frame of each other. That's suspicious. And so what we can do is look at, once it's crossed the statistic threshold of number of people who are doing the exact same behavior, then we can say, okay, this is very unusual. We should look into this and see if it's also malicious. The same thing can be done for legitimate websites. So I had mentioned CoinHive previously, which is, by the way, totally legitimate. We see misuse of CoinHive, a lot of misuse of CoinHive, but it is in fact a legitimate service. It's just the way that people are using it and whether or not they're notifying people that they are using their resources to mine currency. So with CoinHive, we can see a lot of co-occurrences with the websites. The behavior is similar. So we have a lot of malicious domains that are associated with phishing and browser redirects from other legitimate sites. We also see domains that have JavaScript injections that are running miners while people are consuming content. And then we've got some other mining scripts where essentially malicious actors are posing to be CoinHive and getting you to install software or put it on your website, but hard code their wallet address. So you basically set up CoinHive thinking you're going to make some money, but you're really just sending it to somebody else. So one of the things that our team at Cisco Umbrella has worked on, I want to give a shout out for Jeremiah O'Connor and Artsum, two of my colleagues. They developed this classifier that's very effective in identifying phishing traffic. So we start with domains that we've never seen before, we've never resolved, and we use Apache Spark in order to come up with the basis of this model. So we'll do an FQDN classification on the page. We'll pull the source code of the first page of the domain, and then we'll start looking at HTML content classification. And then we'll look to see, okay, now that we know what this looks like and have a general feeling, is this being hosted on infrastructure that we know is legitimate? Is it a really good IP? Is it a good ASN? Or is it in some shady place in Ukraine or elsewhere? And then we can do blocking and threat intelligence once we've gone through that. Going a little bit deeper, we can see that we're basically breaking this out into 4 steps where we have DNS queries coming in. We check to see if the information of that site is listed on something that we know and we trust. And then we will basically do a check on the page to see, okay, is this page that we've never seen before but looks similar to something we have seen? Does it have a box to input credentials or something like that? And then we will basically create a TF-IDF. So this is basically just NLP modeling, so natural language processing. And then we'll do some latent semantic analysis, and then we'll take the cosine of the new site that we just saw with the site that we know is actually legitimate. And then we'll basically train the data set in order to identify domains that are good or bad moving forward. So here's a little bit simpler version of it. We'll go look at all of the exchanges that we know are legitimate. We'll download the code from the site. We'll create a score, and then we will, whenever we see a new site that seems similar, we will create a corpus document and we'll compare it. And this will allow us to determine if this is a phishing site for an exchange without ever having to look at it. So here's one such example. This is lcoinbase.com. It has a score of 99.4. And we can see here some other suspicious things like Coinbase would never have their email registration at a Hotmail account. And they would never do that. So we know that this is suspicious. And here is the live site, which at the time looked just like Coinbase's website, but it actually is in fact malicious. So one thing you have to keep in mind is that the criminal organizations that are behind these type of attacks are using several different revenue vectors. They're not just going to try to phish your credentials. They're also going to run ransomware campaigns, and they're also going to try to install crypto mining software in your environment. It's very profitable. It's pretty anonymous, and that's why they choose to do all of these different vectors for making money. One such case that we found and highlighted a couple of months back was just purely phishing, crypto phishing of wallets. They actually, in 2 months' time, made almost $2 million USD. So it's very lucrative for these malicious actors. And then going to the flip side, ransomware, we see a lot of ransomware still. Ransomware was a little bit riskier of a business before, when you had to have infrastructure to process credit card transactions. But with the invention of cryptocurrency, much easier to make payments, more anonymous, and you're less likely to get caught. And so I think cryptocurrency's invention definitely helped propel ransomware to be as much of a problem as it was and still is. So for ransomware infections, normally you would get infected, right? You would be encrypted, and then you would respond to the incident. You would restore from a backup if you had it, but if you didn't, you would make a decision whether or not, okay, I have to have my data, I should pay, or no, I don't care, I'm not going to pay, I'll just lose the data. But let's say that you have to get it, you end up paying, and then you keep the rest of the cryptocurrency you have in storage just in case something like that happens again. So now I'm going to wrap it up with a couple of final thoughts, and then I'll open it up for questioning. So point number one, we're really witnessing a huge restructuring in the criminal economy as far as cryptocurrency is concerned. This new digital asset has really opened up a lot of vectors for malicious actors to spread more infrastructure and hit more people. Luckily, there are any money laundering laws now where if you move more than one Bitcoin into fiat, so yen, USD, euro, you have to give a certain level of information that will allow you to be tracked. But what criminals have figured out is that with these laws, they have millions of dollars in cryptocurrency that they can't do anything with because it's very hard to get into fiat without being noticed. And so what they've been doing is buying property and things like that to try to get it into an asset and then sell that asset and then get fiat. Second, individuals are in crypto attacks are a much softer target. If I was a hacker, I would much rather go after someone who just started trading cryptocurrencies, even if they only have $15,000 invested, than going after a financial institution that has a lot of security measures and that have been around for a long time. So when you're trading in, if you decide to trade in crypto assets, really take your own security to heart because you are your own bank and you need to have your own security measures. The third thought, there have been some recent shutdowns of very popular exchanges that were being used to basically dry and exchange Bitcoin and other assets in a way that kind of money laundered it. And they've decided to shift away from doing it this way and focus on targeting those smaller businesses that we talked about before that maybe don't have such a great security posture. And the last thing that I want to leave with is protecting your environment is hard, right? There are always going to be new attacks that you have to deal with, but looking at your DNS query logs is a really good first step when you know that a specific attack has to make a request, a DNS request. So it's a very good way of identifying if you might have a problem. But don't just look for web-based miners. So don't just go look for CoinHive in your logs, right? You also want to look for software-based miners like Honeyminer that are running in your environment because they can be a possible indicator that someone externally has installed software in your environment. So with that, I'm going to open it up for questions.
何かご質問ございますでしょうか。